All right, I'm going to read aloud the chapter called Waves of Light. Waves of sound and light do more than just move. They can act in strange and mysterious ways. Have you ever seen your reflection in a funhouse mirror? Light bouncing off a funhouse mirror can make you look pretty strange. Like sound waves that reflect off of a wall, light waves can also reflect off a surface. When light strikes an object, some of the light waves are absorbed. Some waves may go through the object. Still other light waves may be reflected from it. When we see something that doesn't give off its own light, our eyes are seeing reflected light waves. Look at your reflection in a mirror. Did you know you're seeing light waves that have been reflected twice? First, the light reflects off your body. Then that light reflects off of a mirror. A flat, shiny surface, like a mirror, reflects light very precisely. That means light waves bounce off the mirror at exactly the same angle that they struck the mirror. The result is an image that looks much like its source. Sometimes a shiny surface is not flat but curved, like a funhouse mirror or the back of a spoon. This makes light waves reflect at different angles. The image you see won't look exactly like its source because the reflecting surface was curved. The image you see could look very different from the object in front of the curved mirror or spoon. Light makes it bright. The sun is the source of most of the light that brightens our world. Light can come from other sources too. A candle flame produces a soft glowing light. When electricity flows through a light bulb, a thin metal wire inside the bulb heats up. The wire gets so hot that it gives off a bright light. Even some living things can make their own light through chemical reactions. This neat trick is called bioluminescence. Fireflies, for example, store two unique chemicals in their bodies. When these chemicals mix, in the presence of oxygen, tiny bursts of light energy are given off. These are the flashes that fireflies make as they flit around on warm summer nights. Whatever its source, light is the fastest thing in the universe. Unlike sound waves, light waves can travel through a vacuum, such as outer space. In fact, light waves move the fastest in outer space. This is because there's almost nothing in outer space to slow down light waves. Light waves travel through space at 300,000 kilometers, about 186,000 miles per second. We see objects around us when our eyes detect light waves and our brain makes sense of the signal. We see light waves only with a small range of frequencies. It says to visible light is light with frequencies the humans can see. We read about this last week in our electromagnetic readings that we looked about. Honeybees can see ultraviolet light, but humans cannot. Interesting. Light waves we can see are called visible light. However, there are light waves outside of this range we cannot see. For example, the waves of ultraviolet light have higher frequency than visible light waves. We cannot see ultraviolet light, but it can hurt our eyes. However, honeybees and some other animals can see ultraviolet light. Colors and light. If you stand outside on a bright sunny day, the sunlight you see probably doesn't look very colorful. In 1665, English scientist Isaac Newton did some clever experiments and found color in light by using only sunlight and pieces of glass. In his light experiments, Newton used triangular-shaped blocks of glass called prisms. He focused a narrow beam of sunlight on a prism at a certain angle, and then something remarkable happened. The light came out the other side of the prism as a colored band that looked like a miniature rainbow. This spread out pattern of colors is called a spectrum. In Newton's experiments with sunlight and prisms, it was the refraction or the bending of light as he was seeing. Notice it's not reflection, it's refraction. Refraction means the bending of light. As sunlight shines through the prism, the colors that make up sunlight are refracted. That means the different colors of light are bent by different amounts. The colors that make up the spectrum are red, orange, yellow, green, blue, and indigo, which is like a purple color. There was the purple or violet. All of these colors have wavelengths of light that our eyes can see. If light is made up of many colors, why do some things look green and others look blue or purple? Well, the color of an object depends on the way that it either reflects or absorbs certain colors in the light spectrum. For example, a green leaf absorbs all the colors in the spectrum except green. When light hits the leaf, only the color green reflects off of the leaf and back to your eye. A black object absorbs all the colors in the spectrum and reflects no light. An object that looks white doesn't absorb any color and reflects all the colors in the spectrum back to your eye. So here's that prism they talked about with Newton, about how he had that beam of light coming in from the side here, and when it went through this glass, it refracted, or it bent those light waves, and it separated them out into the colors of the rainbow. Okay, and as we saw in our secret message assignment the other day too, that we saw different wavelengths. Here's the red, the orange, and the yellow. Those are the longer wavelengths of colors. And then down here into the kind of the green, blue, purple, those are the short wavelengths of colors, or a higher frequency